All right, for today's portion of the lecture, the last bit before we go live, we're going to be talking about global wind patterns. So I want to once again just take you on a tour of this null school app. Hopefully at this point you're starting to play with this a little bit more often. You're starting to see these beautiful swirls. Maybe you're even starting to see some larger patterns of the larger stuff here. So we're going down, we start off the big global scale, heating and cooling. We got into some of the details of highs and lows. Now we're going to throw it all together, synthesize it into one big picture of the Earth. And to go in there, we're going to head over to the whiteboard, and hopefully you have a little diagram of the Earth here. I should probably label the Earth. Earth, we're showing a little section of the Earth here. And so, as discussed, we have at the equator rising air that will draw air in from the surrounding. Then this rising air will draw air in from the surroundings, head up to this tropopause, and diverge aloft. Make these lines a little bit less thick. And at the polar regions, we have air aloft converging and descending, creating very dry weather at the poles, or high, and very wet weather at the what's going to be called the equatorial low. Just to emphasize that a little bit, we're going to do one more little drawing here. So and just for more dramatic effect, we're going to put some raindrops on there. Oh, that's right. This. Cloud wet. So we talked earlier in the class about how when you have divergence aloft, air is going to flow away from that. Get some purple here. And as the air flows, diverges away from this as the winds aloft diverge away at the top of the troposphere, they're going to be affected by Coriolis force. And these winds aloft are going to start in the northern hemisphere, curving to the right, and in the upper hemisphere, and the southern hemisphere, curving to the left. Until at about 20 to somewhere between 20 and 30 degrees to the equator, you get this pattern of winds aloft, where the winds aloft sort of start off. Let's make this a little wider. Winds aloft start curving, then between about 20 and 30 degrees away from the equator, you get this geostrophic flow known as the jet stream. Let's make this font size a little smaller. Yep. We have this sort of convergence of winds aloft. Now, if you remember from the previous lecture, when you have winds aloft converging, this is going to lead to a high pressure. You're going to get sinking air that's going to pick up heat. And hold on, so we're going to put a little H right here. H. Now we have a special name for this. It's not just any old H, it's the subtropical. Hi. Another term for this the winds at the ground latitude is the horse latitudes, because this tends to be in a region of very fair weather. Fair weather because all this sinking air. All this sinking air tends to be very dry and tends to be spreading away. So any moisture that might be there gets quickly blown away by these winds. Now what'll happen is these winds will return, some of these winds will return back to the turn back towards the equator. It's not actually the equator. We're going to give it another name. Now we're going to call it the equatorial low. Low because it's equatorial low is a little more broad, describes it a little more broadly. And what we're going to see is that because of seasonality, what you actually are going to get is that this region of convergence of the winds is going to be sort of depend a little bit on the seasons. We'll get to more details on that in a bit, but for now, we're just going to draw some arrows from the subtropical high, and they're going to get deflected by the Coriolis forces and winds and friction. And you're going to get these winds going from the subtropical high to the equatorial low, known as the trade winds. Trade winds. And if you're in the tropics, you probably have experienced them. You can notice the poleward western eastern side of an island tends to be a bit wetter than the west side of most tropical islands because of these trade winds blowing from the subtropical high to the equatorial low. Now, in the polar regions, you still have this polar high. Polar high. This will happen whether the Earth rotates or not. And because you have this descending air at the polar regions, you're going to get this very cold air moving from the poles. So that doesn't look very cold, does it? Moving from the poles back towards the equator. But, and indeed, but because you have Coriolis force and you have this convergence of air at about 30 degrees north and south, you also have some subtropical air making its way poleward. As the subtropical air makes its way poleward, Coriolis force is going to deflect it to the right in the northern hemisphere and to the left in the southern hemisphere, giving you these winds that appear to come out of the west. Now, these winds have a name, and it is not Mariah, though that would be freaking awesome. No, the winds, but they call these winds in the mid-latitudes that originate at the subtropical high and move poleward, what they call them is the Westerlies. Westerlies because they come out of the west. This is also the winds that probably are related to the Pet Shop Boys, West End Girls. This the idea being that this is definitely some assumptions about generals that I don't think we should continue to hold on to any longer, but that society women who lived on the west side, upwind of all the factories, were interested in like rugged, gritty young men, and so they would go after the East End boys who were sort of rumble and tough and lived in and worked in the factories and so you have these westerlies, and then meanwhile, these easterly, even though you have these winds coming on the polar high, they're moving equatorward, they get deflected by Coriolis, so they end up coming out of the east. And so we don't have room to write it here on the diagram, so we're sort of a little bit out of planet, but the name for these winds that come out of the polarward east, we call them the Easterlies. Easterlies because they come out of the polarward east. Now, these easterlies tend to be very dry because again, you have descending air. But these westerlies are warm enough and they're picking up moisture over the bodies of water they pass. So what happens is you have these easterlies and westerlies meet somewhere at about, somewhere between about 45 and 60 degrees north, depending on the season and other factors like land and ocean distribution. Now, where these meet, something kind of interesting happens. This polar air is extremely dry and therefore also very dense. So this air is going to be, and so what happens is this air, when they meet, it gets pushed up. The reason it gets pushed up is because your westerlies are pushing up over this dome of very cold, dry air. And so when you push the sort of moisture-laden subtropical air being carried by the westerlies up over that dome of cold polar air, you get condensation, you get lift of air masses. When that lifted air condenses, when that moisture and lifted air condenses, you get cloud formation, and then you get a low pressure system. Yes, you get a low pressure system. So let's put that in here. I'm going to call this this low pressure system goes by a couple names: subpolar low, low. It's also known as the polar front. Polar front, and normally it lies somewhere between about 45 and 70 degrees latitude, but during the big wet spells we get, it gets quite a bit further south. It can make it down all the way to San Diego and even into Baja. And so what you get here are three major circulation cells. You have you have here in the tropics, you have your Hadley circulation. This by far is the most vigorous and dominant of the cells. Let's make this red. Hadley cell. In the mid-latitudes and then the polar regions, this sort of circulation, convection. Call this the polar cell. And then in the mid-latitudes, you have what is known as the Farrell cell. By the way, a little bit of trivia. Pharrell Williams was birthday was today, April 5th. So just a little bit of this and this. And so what you get here is these alternating patterns of winds blowing from polar east to equator west. So, you have these highs and low pressure systems, and that you have highs, and then you have winds blowing from equator west to polar east, and then you have low pressure, and then winds again are blowing the opposite direction. So these alternating patterns of highs and lows and alternating wind directions. Now we're going to talk a little bit more about weather common to these when we get into the main part of the lecture. I was going to wrap up this portion of the lecture with a little drawing of another cloud because we should put another beautiful cloud here. We're going to make this one a little less tall, a little more slanted, and we're going to give it but we're still going to give it plenty of water because, hey, rain clouds are cool. So these alternate main regions of, oh, okay, cool.